Started.
Thank you very much. We move on to Sunny Gupta and will remain in the field of celebrating healthy techniques, and in order to bring pleasure to Robert, he will talking about SDGs, and among other things, his topic is the role of role models. So, Sunny, go ahead. Good morning, everyone. It's a matter of extreme pleasure and gratitude for me to greet you all in this prestigious ICA symposium. I am Sunny Gupta from the group of Professor Albert Duschel, and now I wish to take this wonderful opportunity to take you all for a short journey through the progress of my PhD thesis in my first year here so far. So my PhD thesis gives me a very exciting platform to study and explore in deeper details a very interesting set of cytosolic receptors known as the NODs. They have been so far mainly reported to be playing a crucial role in the recognition of different peptidoglycan components and henceforth elicitation of inflammatory immune responses for, say, a mutation in them is reported to be found in chronic inflammatory bowel disease. But we believe that in addition to such definitions, they could be bearing a much wider implications in the modulation of the immune system, and hence we aim to study their role in the regulation of NF-kappa B and STAT-mediated signaling pathways. So, let me give you a short overview of how the receptor looks like and their mode of action. The receptor comprises of the three domains. At the C-terminal, we have the leucine-rich repeats domain, which is in fact the domain responsible for the recognition of the specific ligand for NOD1 and NOD2. I will come up to these ligands in the subsequent slides. This is followed by the oligomerization domain. NOD is abbreviated for the nucleotide oligomerization domain containing proteins. This is the self-oligomerization receptor, and upon the recognition of the ligand, it leads to an oligomerization. And it is followed by the caspase activity recruitment domain, through which these receptors interact with a common downstream kinase known as RIC or RIC2. Both NOD1 and NOD2 have been reported to be interacting with RIC. This is followed by the subsequent immune response and the inflammatory responses. So taking these points into consideration, we move ahead with our aims, but beforehand we wanted to validate that our experimental procedures are fine, the experiment work on our hand, and if we wanted to validate our method. So here is a very basic preliminary experiment in which we did overexpression studies of the NOD1 and NOD2 in HEC293 cells. These are transient transfection experiments in which the reporter gene is for NF-kappa B is transfected, and here we could see that overexpression of both NOD1 and NOD2, we have a clear elicitation of the NF-kappa B, the constitutive NF-kappa B activation. This fell in line exactly with the already published data, and hence we were successful in validating our method, and hence we could believe that the experiment works in our hand. So here I want to mention briefly that in this study, the amount of DNA being transfected is always leveled up with the pcDNA. It's the dummy DNA, so it's an effect that we observe and rather than a effect of only the concentration of the DNA itself. So here I want to mention briefly the ligands that the NOD receptors recognize. NOD1 recognizes IDA, also locally called gamma glutamyl diaminophilic acid, mainly from the gram-negative bacteria, whereas NOD2 recognizes muramyl dipeptide. This is, as I mentioned earlier, is recognized through the leucine-rich repeat domain. Upon oligomerization by the NODs, there happens the card-card interactions with the downstream kinases, which leads to the subsequent immune response. So now we wanted to see that what effect the ligands have in the activation of NF-kappa B by the NODs compared to when the ligands are absent. And here we could easily observe that IDA presence for NOD1 and MDB's presence for NOD2 bears a high enhancement of the activation of NF-kappa B compared when the ligands are not present. But just comparatively in both these data, we found that the activation of NF-kappa B with IDAP and NOD1 is comparatively a bit more than the case of MDP and NOD2. So at this point of time, we just thought of selecting NOD1 for our subsequent experimental setup. This actually don't mean that we have neglected NOD2 for our study. In fact, experiments regarding NOD2 are extensively going on at present. But for the time being, for my subsequent slides, the data I'm going to discuss with you all deals mainly with NOD1. So now we were interested to see that what could be the possible effects of these domains that I described so far. And I'm greatly thankful to Professor Robert Schottenberger for providing us with this wonderful deletion constructs. And here we could see that when the guard domain is deleted over here, we can easily observe that there is a drastic abolishment of the NF-kappa B activation that is being observed in the wild type. But the most interesting thing here is when the ligand recognition domain, the LLR domain, is deleted, the effect is still maintained as we see in the wild type. So this somehow challenges the role of the ligand itself, and it in fact also falls in line with my very preliminary